Have you ever wondered what's holding the universe together? I mean, really holding it together. You look up at the night sky, you see stars twinkling in their constellations, galaxies spinning in perfect spirals, and everything seems to be exactly where it should be. But here's the thing that'll keep you awake tonight. Most of what's keeping all of that in place is completely invisible. We can't see it, we can't touch it, and until recently, we had no idea it even existed. Ladies and gentlemen, welcome to the most mind-bending mystery in modern science. I'm talking about dark matter, the invisible cosmic glue that makes up over 80% of all matter in the universe. And if that doesn't make you question everything you thought you knew about reality, well, stick around, because we're just getting started. Now, I know what you're thinking. Dark matter sounds like something out of a science fiction movie, right? Some mysterious force that supervillains use to power their doomsday devices. But the truth is far stranger than fiction. Dark matter is real, it's everywhere around us right now, and without it, you wouldn't exist. Neither would Earth, the Sun, or any of the billions of galaxies scattered across the cosmos. Picture this. You're looking at a busy highway at night. You can see the headlights and taillights of cars moving in organized lanes, flowing in predictable patterns. But imagine if those lights were only showing you 1/5 of the actual traffic. The other 80% of vehicles are completely invisible, yet they're still there, still taking up space, still influencing how the visible cars move. That's essentially what we're dealing with when we look out into space. For decades, astronomers stared at galaxies and noticed something deeply unsettling. These massive collections of stars were spinning far too fast. According to everything we knew about physics and gravity, they should have torn themselves apart eons ago, flinging their stars into the void like water droplets spinning off a wet tennis ball. But there they were, holding together perfectly, as if some invisible hand was keeping them intact. The mathematics were undeniable. Either our understanding of gravity was completely wrong, or there was something out there we couldn't see. Something with mass. Something with gravitational pull, something that was doing the heavy lifting to keep the universe from falling apart. And that something, my friends, is what we now call dark matter. But here's where it gets really wild. This isn't just some abstract concept that only affects distant galaxies. Dark matter is flowing through your body right now. As you're watching this video, trillions upon trillions of dark matter particles are passing through you every single second. They're streaming through the walls of your house, through the earth itself, through everything you've ever touched or seen, and you feel absolutely nothing. It's like living in a world where ghost particles are constantly moving through every atom of your being, completely undetected by your senses. These particles barely interact with ordinary matter at all. They don't absorb light. They don't emit light. They don't reflect light. They're essentially invisible to every method we typically use to observe the universe. And yet, their gravitational fingerprints are written across the cosmic landscape. Now, you might be wondering how we even know this stuff exists if we can't see it or feel it. Well, that's where things get absolutely fascinating. Scientists are essentially cosmic detectives, piecing together evidence from the universe's greatest mystery. And the evidence is everywhere once you know how to look. Think about it like this. Imagine you're walking through fresh snow and you see a perfect line of footprints leading across a field. You can't see who made them, but you know someone was there. The footprints are proof of an invisible presence. That's exactly what dark matter does throughout the universe. It leaves footprints in the form of gravitational effects that we can measure and study. When massive clusters of galaxies collide, something extraordinary happens. The regular matter, the stuff we can see, gets slowed down and heated up by electromagnetic forces, but dark matter? It barely interacts at all, so it just passes right through like it's not even there. This creates a separation that we can actually observe, giving us direct evidence that there are two different types of matter behaving in completely different ways. One of the most compelling pieces of evidence comes from something called gravitational lensing. Einstein showed us that massive objects actually bend space and time, creating distortions that act like cosmic magnifying glasses. When we look at distant galaxies through these natural lenses, we can map out exactly where the mass is located. And time after time, we find that there's far more mass-bending light than we can actually see with our telescopes. But perhaps the most stunning evidence comes from the cosmic microwave background, the afterglow of the Big Bang itself. This faint radiation carries with it the blueprint of the early universe, tiny variations in temperature that would eventually grow into galaxies and stars. When scientists analyzed this ancient light, they found patterns that could only be explained if dark matter had been there from the very beginning, helping to shape the structure of everything we see today. So what exactly is this mysterious substance? Well, that's the trillion-dollar question that's keeping physicists awake at night. We know it's not made of ordinary atoms like you and me. It's not black holes. It's not planets floating in the darkness. It's not any kind of matter we're familiar with. It's something entirely different, something that exists in a shadow universe overlapping with our own. The leading candidates have names that sound like they came straight out of a fantasy novel: WIMPs, or weakly interacting massive particles; axions, named after a laundry detergent but far more exotic; sterile neutrinos that barely interact with anything at all. Each of these hypothetical particles would have properties that could explain what we observe, but proving they exist is one of the greatest challenges in modern science. Scientists have built detectors deep underground, shielded from cosmic radiation, hoping to catch just a single dark matter particle as it passes through. They've constructed elaborate experiments with names like xenon and lux, filled with liquid xenon cooled to temperatures colder than outer space, waiting for that telltale flash of light that would signal a dark matter interaction. So far, these particles have remained frustratingly elusive. Meanwhile, at the Large Hadron Collider, the most powerful particle accelerator ever built, physicists are smashing protons together at nearly the speed of light, hoping to create dark matter particles in the lab. The idea is that if we can produce them artificially, we might finally understand what they are and how they behave. But here's what makes this mystery even more profound. Dark matter isn't just some curiosity for scientists to puzzle over. It's absolutely fundamental to our existence. Without dark matter, the universe would be a very different place. The tiny fluctuations in the early universe that grew into galaxies would never have had enough gravitational pull to collapse into the structures we see today. Think of dark matter as the scaffolding upon which the visible universe was built. In the earliest moments after the Big Bang, dark matter began clumping together under its own gravity, creating invisible frameworks that regular matter could then fall into. These dark matter halos became the foundation for galaxy formation, providing the gravitational wells that allowed gas and dust to accumulate and eventually ignite into stars. Our own Milky Way galaxy sits nestled within a massive halo of dark matter, roughly 10 times more massive than all the visible stars combined. This invisible halo extends far beyond the edges of what we can see, creating a gravitational anchor that keeps our galaxy stable and allows it to continue forming new stars. In a very real sense, we live inside a dark matter structure that's been shaping the evolution of our cosmic neighborhood for billions of years. And it's not just galaxies. Dark matter influences the formation of larger structures too. The cosmic web, that vast network of filaments connecting galaxy clusters across billions of light years, is primarily made of dark matter. These invisible highways channel matter and energy across the universe, creating the backbone of cosmic architecture. But perhaps the most mind-blowing aspect of all this is how dark matter challenges our most basic assumptions about reality. We pride ourselves on being observers of the universe, on using our senses and our instruments to understand the world around us. Yet it turns out that most of the universe is completely hidden from us, operating according to rules we're only beginning to glimpse. This isn't just about astronomy or physics. This is about the fundamental nature of existence itself. We're living in a universe where the majority of reality is invisible, where the forces that shaped our world and continue to govern it remain largely mysterious. It's humbling and awe-inspiring at the same time. The implications stretch far beyond what we can see in telescopes. If dark matter particles are streaming through us constantly, what does that mean for our understanding of matter and energy? Could there be entire dark matter structures, maybe even dark matter life forms, existing parallel to our own world? Could there be dark matter planets orbiting dark matter stars in a shadow universe we can barely detect? These questions push us to the very edges of scientific knowledge and philosophical understanding. We're forced to confront the possibility that what we consider normal matter, the stuff that makes up planets and people and everything we've ever known, is actually the cosmic exception rather than the rule. This realization has sparked one of the most ambitious scientific quests in human history. Around the world, teams of researchers are working around the clock to solve what many consider the greatest puzzle of our time. And the methods they're using are nothing short of extraordinary. Deep beneath the mountains of Italy, scientists have carved out massive underground laboratories, shielded by miles of solid rock from the cosmic radiation that constantly bombards Earth's surface. Here, in cathedral-sized chambers filled with ultra-pure water and liquid xenon, they wait in the darkness for dark matter to reveal itself. These detectors are so sensitive they can pick up the recoil of a single atomic nucleus if a dark matter particle happens to bump into it. We're talking about measuring impacts that are trillions of times smaller than anything you could feel. But here's the thing that makes this search so incredibly challenging. Dark matter particles are like the ultimate ghosts. They pass through ordinary matter almost as if it doesn't exist. To give you some perspective, a dark matter particle could travel through a wall of lead stretching from Earth to the nearest star without hitting a single atom. The odds of catching one in our detectors are astronomically small, which is why these experiments have to run for years, recording every tiny vibration, every microscopic flash of light, hoping to spot that one telltale signature. Meanwhile, up in space, telescopes are mapping the invisible architecture of the universe in ways that would have seemed like magic just a few decades ago. The Hubble Space Telescope and its successor, the James Webb Space Telescope, are essentially time machines, looking back billions of years to see how dark matter shaped the cosmos in its infancy. They're studying the subtle distortions in starlight caused by dark matter's gravitational pull, creating maps of invisible structures that dwarf anything we can see. One of the most remarkable discoveries came from studying colliding galaxy clusters, cosmic train wrecks that unfold over millions of years. When these massive structures crash into each other, something extraordinary happens. The visible matter, all those stars and gas clouds, gets tangled up in the collision, slowed down by electromagnetic forces and friction. But dark matter, it barely notices. It passes right through the chaos like it's not even there. This creates what scientists call a smoking gun for dark matter's existence. Using gravitational lensing, researchers can actually see where the mass is located during these cosmic collisions. And time after time, they find that most of the mass, the stuff bending space and time, has separated from the visible matter. It's moved ahead, unimpeded by the electromagnetic forces that slow everything else down. This is dark matter caught in the act, proving that there really are two different types of matter behaving according to completely different rules. But the evidence goes even deeper. Computer simulations of the universe's evolution, when they include dark matter, produce virtual galaxies that look remarkably similar to what we observe in the real cosmos. When scientists run the same simulations without dark matter, the results are completely different. No spiral arms, no stable galaxy clusters, no cosmic web. The universe becomes a chaotic mess that bears no resemblance to reality. These simulations reveal something profound about dark matter's role in cosmic history. In the early universe, just a few 100,000 years after the Big Bang, regular matter was still too hot and energetic to clump together effectively. It was like trying to build sand castles in a hurricane. But dark matter, unaffected by electromagnetic forces, could already begin forming structures. It created invisible scaffolding, gravitational frameworks that gave regular matter something to condense around once the universe cooled down enough. This means that every galaxy, every star, every planet, and ultimately every living thing owes its existence to dark matter's invisible influence. We are literally made possible by something we cannot see, touch, or directly detect. It's as if the entire visible universe is just the tip of an iceberg, with the vast majority of reality hidden beneath the surface. And here's where things get really mind-bending. Some theoretical physicists are proposing that dark matter might not just be invisible particles floating around in space. They're suggesting the possibility of entire dark sectors, parallel worlds made of dark matter that exist alongside our own. Imagine dark matter atoms forming dark matter molecules, dark matter chemistry creating dark matter planets, orbiting dark matter stars. These shadow worlds would be completely invisible to us, but they could be teeming with complexity we can't even imagine. Dark matter galaxies could be forming and evolving according to their own laws, developing structures and patterns that remain forever hidden from our view. It's possible that right here, in the same space you're occupying right now, there could be dark matter structures, maybe even dark matter beings, existing in a reality that barely touches our own. This isn't just science fiction speculation. Some of the most brilliant minds in physics are seriously considering these possibilities. If dark matter makes up 80% of all matter in the universe, why shouldn't it be capable of the same kind of complexity we see in regular matter? The laws of physics don't prevent dark matter from forming intricate structures, they just make those structures invisible to us. The search for dark matter has also led to some of the most creative and ambitious experiments ever conceived. Scientists in Antarctica are using the entire Earth as a filter, looking for high-energy neutrinos that might be produced when dark matter particles annihilate each other in the planet's core. They've turned a cubic kilometer of ice into a giant detector, with thousands of sensors buried deep beneath the surface, waiting for that telltale flash of blue light that would signal a dark matter interaction. Other researchers are taking the opposite approach, going smaller rather than bigger. They're building quantum sensors so precise they could detect the gravitational waves produced by dark matter structures, or the tiny oscillations in space-time that might occur if dark matter is made of ultralight particles. These experiments are pushing the boundaries of what's technologically possible, requiring levels of precision that challenge our understanding of measurement itself. But perhaps the most exciting possibility is that we might create dark matter particles right here on Earth. The Large Hadron Collider, that 27-kilometer ring of superconducting magnets buried beneath Switzerland and France, is designed to recreate the conditions that existed just moments after the Big Bang. When protons collide at nearly the speed of light, the immense energies involved might be sufficient to produce dark matter particles in the laboratory. The challenge is that these particles, if they exist, would immediately escape our detectors without leaving a trace. Scientists have to look for them indirectly, searching for missing energy in the collision debris, like detectives trying to identify a suspect who left the scene without being seen. It's an incredibly difficult task, but if successful, it could revolutionize our understanding of the universe's fundamental structure. What makes this quest even more remarkable is how it's changing the way we think about scientific discovery itself. For centuries, science has been about observing, measuring, and experimenting with things we can see and touch. But dark matter is forcing us to develop entirely new ways of studying reality, to become comfortable with investigating phenomena that might forever remain invisible. This shift in perspective has profound implications beyond just physics and astronomy. It's teaching us that the universe is far stranger and more mysterious than we ever imagined. It's showing us that our human senses, remarkable as they are, reveal only a tiny fraction of what actually exists. Most of reality operates in dimensions and through mechanisms that we can barely comprehend. And yet, Somehow, we're managing to piece together this cosmic puzzle using nothing but mathematics, ingenuity, and an unwavering determination to understand our place in the universe. We're like blind detectives solving a crime by feeling for footprints in the dark, using every indirect clue we can find to build a picture of something we may never directly see. The implications of finally solving the dark matter mystery would be staggering. It wouldn't just answer questions about galaxy formation and cosmic structure. It could open up entirely new branches of physics, new technologies, maybe even new ways of understanding consciousness and existence itself. We're not just looking for invisible particles, we're searching for a deeper truth about the nature of reality. But even if we never directly detect dark matter, even if it remains forever beyond our reach, its influence on our understanding of the universe has already been transformative. It's taught us humility in the face of cosmic mystery, shown us that the universe is far more complex and beautiful than we ever dared imagine. Right now, as you're listening to these words, you're sitting in the middle of the greatest detective story ever told, surrounded by evidence of invisible worlds that shape everything you see and experience. The very atoms in your body were forged in stars that formed within dark matter halos, in galaxies held together by invisible forces that dwarf everything visible. And this brings us to one of the most mind-blowing realizations in all of science. We might be completely wrong about what dark matter actually is. All those underground detectors, all those particle accelerators, all those theoretical models we've been discussing, they're all based on one fundamental assumption. We assume dark matter is made of particles, exotic matter that behaves like stuff we understand, just invisible. But what if that assumption is dead wrong? Some of the most brilliant physicists alive today are proposing something that sounds absolutely insane. Maybe there's nothing mysterious about the matter in the universe at all. Maybe the problem isn't invisible particles. Maybe the problem is that our understanding of gravity itself is fundamentally flawed. Think about this for a second. We've been assuming that Isaac Newton and Albert Einstein got gravity exactly right, and then trying to explain why galaxies don't behave the way their equations predict. But what if those equations are incomplete? What if gravity works differently on cosmic scales than it does here on Earth? This idea is called modified Newtonian dynamics, or MOND for short, and it's causing absolute chaos in the physics community. Instead of invoking invisible matter to explain galactic rotation, Missouri ND suggests that gravity becomes stronger at extremely low accelerations, exactly the kind you'd find at the edges of galaxies. It's like discovering that the rules of the game change when you move from the infield to the outfield. The mathematics are elegant, almost suspiciously so. When you plug MOND into the equations governing galactic rotation, the need for dark matter simply vanishes. Galaxies spin at exactly the speeds you'd expect if gravity behaved slightly differently than we thought. No invisible particles required. But here's where it gets really weird. MOND doesn't just explain galaxy rotation, it predicts it. You can look at a galaxy's visible mass distribution and calculate exactly how fast it should be spinning, and MOND gets the answer right almost every single time. It's like having a key that fits perfectly into a lock we've been struggling with for decades. Yet most physicists remain deeply skeptical, and for good reason. MOND might explain individual galaxies, but it struggles with larger structures. Those massive galaxy clusters, the cosmic web, the patterns in the cosmic microwave background, they all seem to require something like dark matter to make sense. It's as if MOND solves one piece of the puzzle perfectly, while making other pieces even more confusing. This has led to some truly exotic proposals that sound like they belong in a science fiction novel. What if gravity isn't a fundamental force at all, but an emergent property of something deeper? Some theoretical physicists are exploring the idea that gravity might arise from quantum entanglement, the spooky connection between particles that Einstein famously called spooky action at a distance. In this view, the fabric of space-time itself is woven from quantum threads of entanglement, and what we perceive as gravitational attraction is actually information flowing through this quantum network. It sounds completely crazy, but it makes specific, testable predictions about how gravity should behave under extreme conditions. Another mind-bending possibility involves extra dimensions. We experience the universe in 3 dimensions of space, plus 1 of time, but string theory suggests there might be additional dimensions curled up so small we can't detect them directly. What if gravity can leak into these hidden dimensions, becoming weaker over long distances in ways we've never anticipated? This could explain why galaxies seem to need dark matter. Maybe gravity isn't actually weaker at galactic scales. Maybe it's just being diluted by spreading into dimensions we can't see. It's like trying to fill a swimming pool with a hose that has invisible leaks you can't locate. But perhaps the most radical idea of all comes from the cutting edge of quantum mechanics and information theory. Some researchers are proposing that the universe itself might be a hologram, a 2-dimensional information structure that creates the illusion of 3-dimensional space. In this holographic universe, dark matter wouldn't be matter at all. It would be information encoded on the cosmic horizon. I know this sounds absolutely insane, but there's actual mathematical evidence supporting it. When physicists calculate the maximum amount of information that can be stored in any volume of space, they get a number that's proportional to the surface area, not the volume. It's as if the universe is fundamentally 2-dimensional, projecting the illusion of depth like the most sophisticated hologram ever created. If this is true, then everything we think we know about matter and energy might be wrong. Dark matter could be nothing more than information processing errors in the cosmic hologram, glitches in the matrix that create apparent gravitational effects without any actual particles being involved. These ideas push us to the absolute limits of human comprehension. We're talking about possibilities that challenge not just our understanding of physics, but our basic assumptions about the nature of reality itself. And the most incredible part? Some of these theories make predictions we can actually test. The European Space Agency has launched a satellite called Gaia that's measuring the positions and motions of over 1 billion stars with unprecedented precision. If gravity really does behave differently on cosmic scales, Gaia should detect subtle deviations in stellar orbits that pure Newtonian physics can't explain. We're essentially using the entire Milky Way as a laboratory to test the fundamental laws of the universe. Meanwhile, the next generation of gravitational wave detectors will be sensitive enough to detect space-time ripples from dark matter structures, if they exist. These instruments can measure distortions in space smaller than 1/10,000th the width of a proton. They're so precise they have to account for the gravitational effects of cars driving past the facility. But here's what really keeps me up at night thinking about all this. What if we're asking the wrong questions entirely? What if dark matter isn't about particles or modified gravity or extra dimensions? What if it's about something so fundamentally different from our current understanding that we don't even have the conceptual framework to think about it properly? Throughout history, major scientific revolutions have happened when someone realized they were looking at a problem from completely the wrong angle. Before Darwin, people couldn't understand the diversity of life because they were asking how God designed each species individually instead of asking how species change over time. Before Einstein, people couldn't understand the behavior of light because they were asking what medium it travels through instead of asking whether space and time themselves might be flexible. Maybe we're in a similar situation with dark matter. Maybe we're so focused on finding particles or modifying equations that we're missing something much more profound about the nature of existence itself. Some physicists are exploring the possibility that consciousness plays a fundamental role in the universe, that the act of observation doesn't just reveal reality but actually creates it. In this view, dark matter might be the universe's unconscious mind, the vast realm of possibilities that exist but haven't been observed into concrete existence. Others are investigating whether time itself might not be fundamental, but rather an emergent property of something deeper. If time is an illusion created by the flow of information, then dark matter might represent information that's flowing in ways we can't perceive. creating gravitational effects without existing in our temporal framework. These ideas venture far beyond traditional physics, into realms that border on philosophy and metaphysics. But that might be exactly what's needed. The history of science shows us that the biggest breakthroughs often come from thinking about familiar problems in completely unfamiliar ways. What's absolutely certain is that dark matter, whatever it turns out to be, is forcing us to confront the limits of human knowledge in the most profound way possible. We're face to face with the possibility that most of reality operates according to principles we can barely imagine, through mechanisms that may forever remain beyond our direct experience. And yet, somehow, we keep finding ways to probe deeper into the mystery. Every failed experiment teaches us something new about what dark matter isn't. Every successful observation reveals another piece of the cosmic puzzle. We're like archaeologists excavating the deepest layers of reality, uncovering evidence of structures and processes that shaped the universe long before the first stars began to shine. The technology we're developing in the search for dark matter is already revolutionizing other fields. Ultra-sensitive detectors designed to catch dark matter particles are being adapted for medical imaging and nuclear security. Quantum sensors built to measure gravitational waves are finding applications in navigation and geology. The computational techniques used to simulate dark matter structures are helping us understand everything from climate change to the spread of diseases. This is how science works at its best. The pursuit of fundamental knowledge, even when it seems completely abstract and impractical, inevitably leads to discoveries that transform our daily lives in ways we never expected. The scientists who first studied electricity had no idea they were laying the groundwork for the modern world. The physicists who developed quantum mechanics couldn't have imagined they were creating the foundation for computers and smartphones. Right now, the researchers hunting for dark matter are probably doing the same thing, unknowingly developing technologies and insights that will revolutionize civilization in ways we can't even imagine. They're not just solving an abstract puzzle about cosmic architecture, they're potentially unlocking the secrets of reality itself. But even if the practical applications never materialize, even if dark matter remains forever beyond our technological reach, the search itself is changing us in profound ways. It's teaching us that the universe is stranger, more mysterious, and more beautiful than we ever dared imagine. It's showing us that human curiosity and ingenuity can probe the deepest secrets of existence, even when those secrets seem impossibly remote from our everyday experience. Most importantly, it's reminding us that we are part of something much larger than ourselves. The carbon in our bodies, the oxygen in our lungs, the iron in our blood, all of it was forged in the hearts of stars that formed within dark matter halos billions of years ago. We are literally made from cosmic recycling, assembled from elements that have journeyed across the universe multiple times before coming together to create conscious beings capable of contemplating their own origins. This connection between the cosmic and the personal isn't just poetic metaphor, it's scientific fact. The same gravitational forces that sculpt galaxy clusters on scales of millions of light years also influence the formation of planetary systems like our own. The same quantum processes that might explain dark matter also govern the chemical reactions happening in your brain right now as you process these ideas. We exist at the intersection of the infinitely large and the infinitely small, conscious observers embedded in a universe that seems designed to be observed. Whether that's coincidence or something deeper remains one of the great open questions of our time. What's truly staggering is how this mystery is reshaping our understanding of cosmic evolution itself. Picture the universe as a vast construction project that's been underway for nearly 14 billion years. We used to think we understood the blueprints, the materials, and the construction process, but dark matter has revealed that we've been looking at maybe 20% of the actual building site. The cosmic timeline reads like the ultimate origin story, and dark matter is the hidden protagonist driving every major plot point. In the first few 100,000 years after the Big Bang, when the universe was still a hot, dense soup of particles and radiation, dark matter was already getting to work. While ordinary matter was too energetic to settle down and form structures, dark matter particles were quietly clumping together under their own gravitational influence. Think of it like this. Imagine you're trying to build a house during a hurricane. The regular building materials, your lumber and bricks and concrete, are getting blown around by massive winds. But somehow, you have access to invisible scaffolding that's completely unaffected by the storm. That scaffolding can start forming the framework of your house, even while the visible materials are still chaos. That's essentially what dark matter did for the early universe. By the time ordinary matter had cooled down enough to start forming atoms, dark matter had already constructed an invisible skeleton for the cosmos. These dark matter frameworks became gravitational wells, cosmic valleys where regular matter could finally settle and begin the long process of star and galaxy formation. Without this head start, the universe would have remained a smooth, featureless expanse with no structure at all. But here's where the story gets even more incredible. Dark matter didn't just provide the initial framework and then step back. It's been actively shaping cosmic evolution ever since, like an invisible conductor, orchestrating a symphony that's been playing for billions of years. Take our own Milky Way galaxy. Right now, as you're sitting wherever you are, you're embedded within a massive dark matter halo that extends far beyond the visible edges of our galaxy. This halo is roughly spherical, about 10 times more massive than all the stars you can see in the night sky combined. It's like living inside an enormous invisible sphere that's been our cosmic address for the entire history of our solar system. This dark matter halo isn't static. It's a dynamic, evolving structure that's constantly interacting with smaller dark matter clumps falling into it from the cosmic web. These interactions create ripples and disturbances that influence how gas flows within the galaxy, affecting where and when new stars form. In a very real sense, the birth of every star, including our own sun, was influenced by the invisible architecture of dark matter. Scientists have used supercomputers to run detailed simulations of this process, and the results are absolutely mind-blowing. They can start with the conditions of the early universe and watch dark matter evolve over cosmic time, forming the scaffolding for everything we see today. These simulations produce virtual galaxies that look remarkably similar to real ones, complete with spiral arms, central bulges, and satellite galaxies. But when they run the same simulations without dark matter, the results are completely different. No stable galaxies form, no spiral structures emerge. The universe becomes a chaotic mess of gas clouds that never organize into anything resembling the cosmic architecture we observe. It's like trying to build a skyscraper without a steel frame. The whole structure just collapses under its own weight. This realization has profound implications for how we think about our place in the universe. We're not just observers of cosmic evolution, we're products of it. Every atom in your body has been shaped by processes that depend fundamentally on dark matter's invisible influence. The calcium in your bones was forged in stars that formed within dark matter halos. The iron in your blood was created in supernova explosions that were triggered by stellar evolution within dark matter-dominated galaxies. You are literally made from materials that have been processed through dark matter structures multiple times over the course of cosmic history. It's as if the universe has been running a vast recycling program for billions of years, with dark matter serving as the invisible infrastructure that makes the whole system possible. And this brings us to one of the most fascinating aspects of the dark matter mystery, the role of time itself. We experience time as a steady flow from past to future. But on cosmic scales, the relationship between time and structure formation is far more complex. Dark matter doesn't just exist in space, it exists in what physicists call phase space, a mathematical realm that includes not just where particles are, but how fast they're moving and in what directions. The evolution of dark matter structures over cosmic time creates intricate patterns in this phase space, like cosmic fingerprints, that record the entire history of gravitational interactions. Some of these patterns are so delicate they can preserve information about events that happened billions of years ago. The way dark matter streams through our galaxy today carries echoes of ancient collisions with smaller galaxies that were absorbed long before the Earth formed. It's like reading a cosmic memory bank written in the language of invisible particles. This has led to some truly remarkable discoveries about our galaxy's violent past. By carefully mapping the motions of stars in the Milky Way, astronomers have identified the remnants of ancient galactic mergers, cosmic train wrecks that happened when dark matter halos collided and merged billions of years ago. These stellar streams are like cosmic archaeology, revealing the hidden history of our cosmic neighborhood. But perhaps the most mind-bending aspect of all this is how it's changing our understanding of what it means to exist in the universe. We used to think of space as mostly empty, with occasional islands of matter scattered here and there. Dark matter has revealed that space is actually full of invisible structure, a vast network of filaments and nodes that connects every galaxy to every other galaxy across billions of light years. This cosmic web is like the universe's nervous system, channels of dark matter that funnel matter and energy across cosmic distances. Galaxies form at the intersections of these filaments, like cities built at the confluence of major rivers. The empty spaces between galaxies aren't empty at all. They're filled with dark matter streams flowing along invisible highways. And here's something that will absolutely blow your mind. We can actually see this cosmic web in action. Using the most powerful telescopes ever built, astronomers have detected faint streams of gas flowing along dark matter filaments, cosmic rivers that span hundreds of millions of light years. These observations provide direct evidence that the invisible scaffolding of dark matter is actively channeling the flow of ordinary matter throughout the universe. It's like discovering that what you thought was empty space is actually filled with invisible conveyor belts, moving matter and energy, according to a grand cosmic plan that's been unfolding for billions of years. Every galaxy, every star, every planet exists where it does because of currents in this dark matter ocean that we're only now beginning to map. This realization is forcing us to completely reimagine what the universe looks like on the largest scales. Instead of a sparse collection of galaxies floating in empty space, we're looking at a densely interconnected network, where everything influences everything else through gravitational threads we can't see directly. The implications for our understanding of cosmic evolution are staggering. Galaxy formation isn't a random process where matter occasionally clumps together by chance. It's a highly orchestrated dance where dark matter provides the choreography, guiding the formation of structure according to patterns that were established in the first moments after the Big Bang. And this brings us back to one of the most profound questions in all of science. Why does the universe seem so perfectly tuned for complexity and life? The amount of dark matter, its properties, the way it interacts with ordinary matter, all of these factors have to fall within very narrow ranges for galaxies and stars to form at all. If there were slightly less dark matter, the universe would have expanded too quickly for structures to condense out of the primordial soup. If there was slightly more, everything would have collapsed into black holes before stars could form. The cosmic recipe seems to be balanced with extraordinary precision, as if the universe knew exactly what ingredients it needed to create the conditions for complexity and consciousness. Some physicists interpret this as evidence for what's called the anthropic principle, the idea that the universe appears fine-tuned for life because we're here to observe it. In an infinite multiverse with countless variations, we naturally find ourselves in one of the rare universes where the parameters allow for observers like us to exist. Others see it as pointing toward deeper principles we don't yet understand, fundamental laws that govern not just how the universe evolves, but why it has the specific properties it does. Maybe dark matter isn't just an accident of cosmic evolution, but a necessary component of any universe capable of generating the kind of complexity that leads to consciousness. These questions push us to the very edges of scientific inquiry, into realms where physics meets philosophy, and where the search for dark matter becomes part of the larger quest to understand why anything exists at all. We're not just looking for invisible particles, we're trying to understand the deepest principles that govern reality itself. And the tools we're developing for this search are becoming increasingly sophisticated and creative. Scientists are now using artificial intelligence to analyze vast datasets from dark matter simulations, looking for patterns that human minds might miss. Machine learning algorithms trained on millions of virtual galaxies can identify subtle signatures of dark matter interactions that would take human researchers decades to find. Other teams are developing quantum sensors, so sensitive they could detect the gravitational effects of dark matter substructures within our own galaxy. These devices push the boundaries of measurement precision, requiring technologies that didn't exist even a few years ago. It's like trying to hear a whisper from across a crowded stadium, except the whisper is in a language we don't understand and we're not even sure anyone is speaking. But perhaps the most exciting development is how the search for dark matter is converging with other frontiers of physics. The same theories that attempt to explain dark matter also make predictions about the nature of dark energy, the mysterious force that's accelerating the expansion of the universe. These two dark components might be intimately connected, different aspects of a deeper reality that we're only beginning to glimpse. Some cutting-edge theories propose that dark matter and dark energy are manifestations of the same underlying field, a cosmic fluid that behaves like matter in some regions of space and like energy in others. If this is true, then solving the dark matter mystery might simultaneously unlock the secrets of cosmic acceleration and the ultimate fate of the universe. The mathematical frameworks being developed to describe these possibilities are among the most sophisticated ever created by human minds. They involve concepts like extra dimensions, supersymmetry, and quantum field theory in curved spacetime, ideas that push the limits of what our brains can conceptualize. Yet somehow, these abstract mathematical structures make specific, testable predictions about how the universe should behave. And that's what makes this whole quest so remarkable. We're using pure mathematics to probe the deepest mysteries of existence, transforming abstract equations into concrete experimental predictions. It's as if the universe itself is written in mathematical language, and we're slowly learning how to read its most fundamental chapters. The next few decades promise to be absolutely crucial for dark matter research. New experiments coming online will be sensitive enough to detect even the faintest whispers of dark matter interactions. Space-based telescopes will map the cosmic web in unprecedented detail. Quantum computers might crack theoretical problems that are impossible for classical computers to solve. But regardless of what we discover, the search for dark matter has already transformed our understanding of the universe in ways that will resonate for generations. It's taught us that reality is far stranger and more mysterious than we ever imagined, that the visible world we experience is just the tip of an iceberg whose depths we're only beginning to fathom. Most importantly, it's shown us that human curiosity and ingenuity can probe the deepest secrets of existence, even when those secrets seem impossibly remote from our everyday experience. We may be small creatures on a tiny planet, but our minds can reach across the cosmos and grapple with mysteries that span billions of years and countless galaxies. The story of dark matter is really the story of human consciousness encountering the limits of the knowable universe. And in that encounter, we discover not just the nature of cosmic architecture, but something profound about what it means to be thinking beings, embedded in a reality that seems designed to be contemplated, questioned, and gradually understood. Right now, as dark matter streams through your body and shapes the galaxy around you, you're part of this cosmic story. You're made of atoms forged in dark matter-dominated structures, living on a planet that exists because dark matter made galaxy formation possible, thinking thoughts that arise from neural networks, powered by energy that ultimately traces back to the invisible scaffolding of the universe. The more we delve into dark matter's influence on cosmic evolution, the more we realize we're dealing with something that operates on timescales that dwarf human comprehension. We're talking about processes that unfold over billions of years, where what seems like empty space today was once the site of cosmic construction projects that make our greatest engineering achievements look like children's toys. Consider this mind-bending fact. The dark matter halo surrounding our galaxy has been accumulating and organizing itself for over 10 billion years. That's more than twice the age of our entire solar system. The invisible architecture that cradles our cosmic neighborhood was already ancient when the first solid matter began condensing into what would eventually become planets and moons. But here's where things get really wild. Dark matter doesn't just influence the large-scale structure of the universe. It's actively involved in the most intimate details of how galaxies evolve. Every time a small galaxy falls into a larger one, every time two cosmic neighbors merge in a gravitational dance that spans millions of years, dark matter is choreographing the entire performance. These galactic mergers aren't gentle affairs. When dark matter halos collide, they create gravitational waves that ripple through space-time itself, distortions in the very fabric of reality that we're only now learning how to detect. The recent discovery of gravitational waves from merging black holes was just the beginning. Scientists are developing instruments sensitive enough to pick up the gravitational signatures of dark matter structures colliding on cosmic scales. Imagine being able to listen to the universe's construction process, to hear the gravitational music created when invisible scaffolding shifts and reorganizes itself across billions of light years. We're developing the cosmic equivalent of extremely sensitive microphones, devices that can detect the subtle vibrations in space-time created when dark matter does its heavy lifting. But perhaps the most fascinating aspect of all this is how dark matter seems to create what scientists call the Goldilocks zones of cosmic structure formation. Just like the fairy tale character who found porridge that was not too hot and not too cold, but just right, dark matter appears to create gravitational environments that are perfectly suited for the formation of stars and planets. In regions where dark matter is too dense, gravitational forces become so strong that matter gets compressed into black holes before it can form stars. In regions where dark matter is too sparse, gravity isn't strong enough to pull gas and dust together into stellar nurseries. But in those special zones where the dark matter density is just right, you get the conditions necessary for star formation, planetary systems, and ultimately, the possibility of life. Our own solar system exists in one of these cosmic sweet spots, nestled within a dark matter halo that's been maintaining the perfect gravitational environment for billions of years. It's as if the universe has been fine-tuning the conditions for complexity and consciousness long before the first atoms began glowing in primordial stars. This realization has profound implications for the search for extraterrestrial life. If dark matter plays such a crucial role in creating habitable environments, then the distribution of dark matter throughout the universe might serve as a cosmic map for where we're most likely to find other forms of life. The invisible architecture that we can't see directly might be the key to understanding where consciousness has emerged elsewhere in the cosmos. Scientists are already beginning to use dark matter simulations to identify the most promising regions of space for harboring life-bearing planets. They're looking for cosmic neighborhoods with dark matter distributions similar to our own, places where the gravitational conditions have remained stable for the billions of years necessary for biological evolution to unfold. But even as we develop these sophisticated tools for mapping the invisible universe, dark matter continues to surprise us with phenomena that challenge our deepest assumptions about how reality works. One of the most puzzling discoveries involves what scientists call dark matter hurricanes, vast streams of invisible particles that flow through our galaxy like cosmic weather systems. These dark matter streams are the remnants of ancient galactic collisions, rivers of invisible particles that have been flowing through the Milky Way for hundreds of millions of years. They're completely undetectable by normal means, but their gravitational effects can be measured by observing how they influence the motions of nearby stars. What makes this even more incredible is that Earth periodically passes through these dark matter streams as our solar system orbits the galactic center. Right now, you might be sitting in the middle of a dark matter hurricane, with trillions of invisible particles flowing past you at hundreds of kilometers per second. You feel nothing, but sensitive detectors on Earth might actually be able to pick up subtle changes in the dark matter flux as these cosmic weather systems move through our neighborhood. This discovery has opened up entirely new possibilities for dark matter detection. Instead of just waiting passively for dark matter particles to interact with our instruments, we can now time our experiments to coincide with periods when Earth is passing through the densest parts of these invisible streams. It's like trying to catch fish by positioning your net where you know the school will be swimming. But the more we learn about these dark matter flows, the more complex the picture becomes. Different streams have different compositions, different velocities, different origins. Some are the remnants of galaxies that were torn apart billions of years ago. Others are fresh debris from ongoing galactic interactions. The invisible space around us is filled with archaeological evidence of cosmic events that happened long before our planet existed. One particularly intriguing discovery involves what researchers are calling dark matter wakes, disturbances in the invisible medium created by the passage of massive objects through space. Just like a boat creates a wake as it moves through water, galaxies and galaxy clusters create persistent disturbances in the dark matter field as they move through the cosmos. These wakes can persist for hundreds of millions of years, like fossil imprints of cosmic motion frozen in the invisible medium. By studying the patterns of these disturbances, scientists can reconstruct the orbital histories of entire galaxy clusters, tracing their movements backward through cosmic time to understand how the largest structures in the universe have evolved. It's like having access to a cosmic surveillance system that's been recording the movements of every major object in the universe for billions of years. The information is all there, encoded in the subtle patterns of dark matter distribution, waiting for us to develop the tools and techniques necessary to read this invisible archive. But perhaps the most mind-bending possibility involves what some theoretical physicists call dark matter archaeology. If dark matter particles can cluster and organize themselves into complex structures over cosmic time, then the invisible scaffolding around us might contain information about the entire history of our cosmic neighborhood. Imagine if dark matter could form something like invisible fossils, persistent structures that preserve information about long-vanished cosmic events. The dark matter halo surrounding our galaxy might contain readable records of every major collision, every period of intense star formation, every cosmic catastrophe that has shaped our galactic home over billions of years. Some researchers are exploring whether advanced civilizations might be able to use dark matter as a kind of cosmic storage medium, encoding information in the invisible structures that permeate space. If dark matter can maintain complex organizational patterns over cosmic time, it might serve as the ultimate library, a repository of information that could survive the death of stars and the dissolution of entire galaxies. This isn't just wild speculation. The mathematical models that describe dark matter structure formation suggest that information can indeed be preserved in invisible networks for extraordinary periods of time. The challenge is figuring out how to read this cosmic hard drive, how to extract meaningful data from patterns in a medium we can barely detect. The implications go far beyond just understanding the history of our own galaxy. If dark matter can serve as an information storage and transmission medium, it might provide a means of communication that transcends the limitations of electromagnetic radiation. Advanced civilizations might be encoding messages in dark matter structures, broadcasting information across the cosmos in ways we haven't even begun to consider. This possibility has sparked intense interest in developing what researchers call dark matter archaeology techniques, methods for extracting historical information from the invisible structures that surround us. It's like trying to read a book written in invisible ink, using only the subtle shadows it casts on the pages around it. The technology required for this kind of investigation pushes the boundaries of what's currently possible, but the potential rewards are staggering. We might be surrounded by a vast cosmic library that contains the complete history of our galaxy, the records of countless civilizations that have risen and fallen over billions of years, all encoded in structures made of particles we can't even see directly. But even if we never crack the code of dark matter archaeology, the search itself is revealing profound truths about the nature of information and its role in cosmic evolution. The patterns we observe in dark matter distribution aren't random. They're the result of information processing on a cosmic scale, the universe organizing itself according to principles we're only beginning to understand. This brings us to one of the most profound questions in all of science. Is the universe itself a kind of information processing system? Are the structures we observe, from the smallest quantum particles to the largest galactic clusters, actually computational processes running on a cosmic scale? Some cutting-edge theories in physics suggest that reality itself might be informational at its deepest level, that what we perceive as matter and energy are actually different ways that information organizes itself in space and time. If this is true, then dark matter might not be exotic particles at all, but rather the universe's way of processing information that we don't have direct access to. This informational view of reality has startling implications for how we think about consciousness and its place in the cosmic order. If the universe is fundamentally computational, then conscious observers like us might not be accidents of cosmic evolution, but rather necessary components of the universe's information processing system. In this view, the emergence of consciousness isn't a random byproduct of stellar nucleosynthesis and biological evolution. It's the universe developing the capacity to observe and understand itself, to process information about its own structure and evolution. We're not separate from the cosmic information system, we're part of it, conscious nodes in a vast network that spans galaxies. This perspective transforms the search for dark matter from a hunt for exotic particles into something much more profound, an investigation into the fundamental nature of information and its role in creating the reality we experience. We're not just trying to identify invisible matter, we're exploring the deepest levels of cosmic organization. And this brings us to perhaps the most remarkable aspect of the entire dark matter mystery, how it's changing our understanding of what it means to be observers in the universe. We used to think of ourselves as external spectators, looking at the cosmos from the outside and trying to figure out how it works. But dark matter has revealed that we're embedded within the very structures we're trying to understand. The dark matter halo that surrounds our galaxy isn't just our cosmic address, it's part of our extended environment. The invisible streams flowing through our solar system aren't just curiosities for physicists to study, they're components of the medium in which we exist. We're not separate from dark matter, we're immersed in it, shaped by it, and ultimately dependent on it for our very existence. This realization has profound implications for how we approach the search for extraterrestrial intelligence. If consciousness emerges naturally in environments shaped by dark matter structures, then the invisible architecture of the universe might serve as a guide for where we're most likely to find other thinking beings. But it also raises deeper questions about the nature of observation itself. If dark matter is streaming through our bodies constantly, interacting with the atoms in our brains in ways we can't detect, might it be influencing our thoughts and perceptions in subtle ways? Could the invisible medium in which we're embedded be playing a role in consciousness itself? These questions push us to the very edges of scientific inquiry, into realms where physics meets neuroscience and philosophy. We're not just studying invisible particles anymore, we're investigating the fundamental relationship between matter, information, and consciousness in a universe that's far stranger than we ever imagined. The search for dark matter has become much more than a hunt for missing mass. It's evolved into a comprehensive investigation of reality's deepest structures, a quest that's revealing connections between the cosmic and the personal that we're only beginning to appreciate. And as we develop ever more sophisticated tools for probing the invisible universe, we're discovering that the boundary between observer and observed is far more fluid than we once believed. We're not just studying dark matter, we're part of the dark matter story, conscious participants in a cosmic narrative that's been unfolding for nearly 14 billion years. This participatory relationship with the universe is perhaps the most profound discovery to emerge from dark matter research. We're not external observers trying to decode a mysterious cosmos from the outside. We're internal components of the very system we're trying to understand, conscious elements of a universe that seems designed to investigate itself through beings like us. The dark matter streaming through your body right now carries with it the entire history of cosmic structure formation. The invisible particles passing through your brain have been part of galactic collisions, stellar births, and planetary formations across billions of years. You're not just made from recycled stardust. You're embedded in an invisible medium that connects you to every structure in the observable universe. And somehow, through processes we don't yet understand, this invisible cosmic web has given rise to conscious beings capable of contemplating their own origins and place in the grand scheme of existence. The universe has evolved observers who can study dark matter, question the nature of reality, and gradually piece together the story of cosmic evolution from the inside out. That might be the most remarkable discovery of all, not just that dark matter exists, but that the universe has become conscious of its own invisible architecture through beings like us. We are the cosmos investigating itself, using tools and techniques that would have seemed like magic just decades ago to probe mysteries that span the deepest levels of reality. The story of dark matter is really the story of cosmic self-awareness emerging from the invisible structures that hold everything together. And in that emergence, we discover not just the nature of invisible particles, but something profound about what it means to be thinking beings in a universe that seems perfectly designed to be understood by minds like ours. The implications of this cosmic self-awareness go even deeper when we consider how dark matter might be influencing the very process of discovery itself. Think about this for a moment. Every breakthrough in dark matter research, every ingenious experimental design, every mathematical insight that brings us closer to understanding the invisible universe, all of these emerge from brains that are constantly being permeated by the very phenomenon they're studying. It's as if the universe has created a feedback loop of investigation, where the invisible medium that shapes cosmic structure also flows through the neural networks of the scientists trying to understand it. We're not just observers of dark matter, we're integrated components of the same system, conscious elements that have emerged from billions of years of structure formation, guided by invisible forces. This raises absolutely fascinating questions about the relationship between cosmic evolution and the development of intelligence. Is it coincidence that consciousness has emerged in a universe dominated by invisible matter, or is there something deeper at work? Some theoretical physicists are beginning to explore whether the information processing capacity of dark matter structures might be connected to the emergence of complex systems, including life and consciousness. Consider the staggering computational power that would be required to organize matter across billions of light years, to coordinate the formation of galactic clusters and cosmic webs, to maintain the precise gravitational relationships that keep entire regions of space stable for billions of years. If dark matter is somehow processing information on these cosmic scales, then the invisible medium flowing through us might possess computational capabilities that dwarf anything we can currently imagine. But here's where things get truly mind-bending. Recent advances in quantum information theory suggest that information processing might not require the kind of classical computational architecture we're familiar with. Quantum systems can process vast amounts of information through mechanisms like entanglement and superposition, performing calculations that would be impossible for classical computers. What if dark matter operates according to quantum information principles we haven't discovered yet? What if the invisible particles streaming through your body right now are part of a vast quantum computational network that spans the observable universe? The mathematical frameworks describing quantum field theory in curved spacetime certainly allow for such possibilities, even if we don't yet have the experimental tools to test them directly. This quantum perspective on dark matter opens up possibilities that sound like they belong in the realm of science fiction, but are actually grounded in rigorous mathematical physics. If dark matter can maintain quantum coherence across cosmic distances, it might serve as a kind of universal communication network, allowing information to flow instantaneously between widely separated regions of space. Einstein famously called quantum entanglement spooky action at a distance, but what he viewed as a troubling feature of quantum mechanics might actually be a fundamental aspect of how the universe organizes itself on the largest scales. If dark matter particles can become entangled across galactic distances, then the invisible medium surrounding us might be far more interconnected than we ever imagined. Some cutting-edge research in quantum cosmology is exploring whether the entire observable universe might be a single, vast quantum system, with dark matter serving as the medium through which quantum information propagates across space and time. In this view, what we perceive as separate galaxies and galaxy clusters are actually connected components of an enormous quantum computer that's been running calculations for nearly 14 billion years. The implications are staggering. If this is true, then every observation we make, every experiment we perform, every thought we think might be influencing the quantum state of the entire universe in subtle but measurable ways. We wouldn't just be studying dark matter, we'd be participating in its computational processes, conscious subroutines in a cosmic algorithm that's far too complex for us to comprehend directly. This brings us to one of the most profound questions in modern physics. What is the relationship between consciousness and quantum mechanics? For nearly a century, physicists have debated whether the act of observation plays a fundamental role in quantum systems, whether conscious measurement somehow causes the collapse of quantum superposition states. Most physicists today believe that consciousness isn't required for quantum decoherence, that any sufficiently complex interaction can cause quantum systems to behave classically. But a minority of researchers continue to explore whether consciousness might have special properties that make it uniquely capable of influencing quantum processes. If dark matter operates according to quantum principles, and if consciousness can indeed influence quantum systems, then our investigation of the invisible universe might be more participatory than we realize. Every time we design an experiment to detect dark matter, every time we formulate a theory to explain its properties, we might be subtly influencing the very phenomenon we're trying to study. This isn't mysticism or New Age speculation. It's a legitimate area of research that combines quantum field theory with information science and consciousness studies. The mathematics are incredibly complex, but they suggest that the boundary between observer and observed in quantum systems is far more fluid than classical physics would suggest. And if dark matter really is processing information on cosmic scales, then our efforts to understand it might be part of a much larger computational process that we're only beginning to glimpse. We could be components in the universe's attempt to understand itself, conscious elements that have emerged from invisible structures and are now investigating their own origins. The experimental implications of this quantum information perspective are just starting to be explored. If dark matter particles can maintain quantum coherence across cosmic distances, then detecting them might require quantum measurement techniques that are far more sophisticated than anything currently available. Scientists are beginning to develop quantum sensors that exploit entanglement and superposition to achieve measurement precision that's limited only by fundamental quantum uncertainty. These devices might be capable of detecting dark matter interactions that are completely invisible to classical detectors, opening up entirely new windows into the invisible universe. But the most exciting possibility involves using quantum error correction techniques to filter out noise and extract meaningful signals from the quantum vacuum itself. If dark matter really is part of a cosmic quantum computational network, then the seemingly empty space around us might actually be filled with quantum information that we can learn to decode. Imagine being able to read the quantum information stored in the vacuum of space, to extract data about cosmic evolution that's been encoded in the quantum fluctuations of the invisible medium. We might discover that empty space isn't empty at all, but rather a vast quantum hard drive containing the complete computational history of the universe. These ideas push the boundaries of what's currently possible, but they're based on solid mathematical foundations that combine general relativity, quantum field theory, and information science in novel ways. The technology required to test these theories is still decades away, but the conceptual frameworks are already being developed by researchers working at the intersection of fundamental physics and quantum computing. What makes this even more remarkable is how these quantum perspectives on dark matter are converging with advances in artificial intelligence and machine learning. The same mathematical techniques used to train neural networks and analyze big data are being adapted to search for patterns in dark matter simulations and experimental data. AI systems are now capable of identifying subtle correlations in cosmic structure that human researchers might miss, finding signatures of dark matter interactions buried in noise that would take traditional analysis methods years to uncover. Machine learning algorithms trained on millions of virtual galaxies can predict where dark matter should be most detectable, optimizing experimental strategies in ways that were impossible just a few years ago. But perhaps the most intriguing development involves using AI to explore the possibility that dark matter itself might be processing information in ways analogous to artificial neural networks. If invisible particles can form complex organizational patterns that persist across cosmic time, they might be capable of learning and adaptation in ways we're only beginning to understand. Some researchers are investigating whether the large-scale structure of the universe shows signs of optimization and self-organization that might indicate information processing capabilities in dark matter networks. They're looking for patterns in cosmic evolution that suggest the invisible medium isn't just passively responding to gravitational forces, but actively organizing itself according to computational principles. The implications go far beyond just understanding dark matter. If the universe really is processing information on cosmic scales, then the emergence of life and consciousness might not be accidents of stellar nucleosynthesis and biological evolution. They might be inevitable outcomes of a cosmic computational process that's been running for billions of years. This computational view of cosmic evolution suggests that complexity and intelligence aren't rare accidents in an otherwise lifeless universe, but rather natural expressions of information processing, capabilities that are built into the fundamental structure of reality itself. Dark matter might be the medium through which the universe computes its own evolution, generating ever more complex patterns that eventually give rise to conscious observers capable of understanding the computational process that created them. And this brings us full circle to one of the most profound realizations in all of science. We might not just be studying the universe, we might be the universe studying itself. The consciousness that allows us to contemplate dark matter, to design experiments and formulate theories, might be an emergent property of the same invisible computational network that we're trying to understand. In this view, every scientific discovery is an act of cosmic self-recognition, a moment when the universe becomes aware of its own structure and evolution through conscious beings that have emerged from its invisible scaffolding. The search for dark matter isn't just an investigation of exotic particles, it's part of the universe's ongoing attempt to comprehend its own deepest nature. But even as we explore these mind-expanding possibilities, we're reminded that the ultimate nature of dark matter remains one of the greatest unsolved mysteries in science. Despite decades of research and increasingly sophisticated experiments, we still don't know what dark matter actually is, or how it fits into our understanding of fundamental physics. The failure to detect dark matter particles directly has led some researchers to question whether we're looking for the right thing in the right way. Maybe dark matter isn't made of particles at all, but represents something even more fundamental about the nature of space and time themselves. Some of the most radical theories propose that dark matter might be a manifestation of extra dimensions, regions of space that exist parallel to our own, but remain largely hidden from direct observation. In these higher dimensional models, what we perceive as dark matter effects might actually be gravitational influences leaking into our three-dimensional space from invisible dimensions that exist alongside our own. Other theories suggest that dark matter might be connected to the quantum structure of space-time itself, arising from quantum fluctuations in the vacuum that create apparent gravitational effects without requiring any actual particles. These quantum vacuum models propose that empty space isn't really empty, but filled with virtual particles that pop in and out of existence so quickly we can't detect them directly. The mathematics describing these possibilities involve some of the most advanced concepts in theoretical physics, including string theory, loop quantum gravity, and causal set theory. These frameworks attempt to describe reality at the most fundamental level, where space and time themselves might emerge from deeper quantum structures that we can barely imagine. What's particularly fascinating is how these different approaches to understanding dark matter are beginning to converge on similar conclusions about the nature of reality itself. Whether we're talking about information processing, extra dimensions, or quantum vacuum effects, all of these theories suggest that the universe is far more complex and interconnected than our everyday experience would suggest. The invisible medium that permeates all of space might not just be exotic matter, but rather a fundamental aspect of reality that connects everything to everything else in ways we're only beginning to comprehend. Dark matter might be the cosmic equivalent of the quantum field that underlies all existence, the invisible foundation from which both matter and consciousness emerge. This unification of different theoretical approaches represents one of the most exciting developments in modern physics. Instead of having multiple competing theories that each explain only part of the dark matter puzzle, researchers are beginning to develop comprehensive frameworks that could potentially explain not just invisible matter, but the fundamental nature of space, time, information, and consciousness all at once. The experimental challenges involved in testing these unified theories are enormous, requiring technologies that push the absolute limits of measurement, precision, and engineering capability. But the potential payoffs are equally enormous. We might finally understand not just what dark matter is, but how it fits into a complete picture of reality that includes everything from quantum mechanics to cosmic evolution to the emergence of consciousness itself. And as we stand on the threshold of these potential breakthroughs, it's worth reflecting on how far we've come in our understanding of the invisible universe. Just a century ago, we didn't even know that other galaxies existed beyond our own Milky Way. The idea that most of the universe might be invisible would have seemed like pure fantasy. Today, we're not just aware of dark matter's existence, we're on the verge of understanding its deepest properties and its role in cosmic evolution. We've developed technologies that can measure distortions in space-time smaller than a proton, detect individual particle interactions in underground laboratories, and map the invisible architecture of the universe across billions of light years. But perhaps most importantly, we've come to understand that consciousness itself might be an integral part of the cosmic story, not just an accidental byproduct of stellar nucleosynthesis and biological evolution, but a fundamental aspect of how the universe processes information and understands its own nature. The search for dark matter has evolved from a simple hunt for missing mass into a comprehensive investigation of reality's deepest structures, a quest that's revealing profound connections between the cosmic and the personal, between the physics of invisible particles and the nature of conscious experience. And as we continue pushing forward into this invisible frontier, we're discovering that the universe is not just stranger than we imagine, it's stranger than we can imagine. The dark matter flowing through your body right now connects you to cosmic structures spanning billions of years and countless galaxies, making you part of a story that began with the Big Bang and continues to unfold through conscious observers like yourself. You are not separate from the cosmic mystery of dark matter. You are part of its solution, a conscious element in the universe's ongoing investigation of its own invisible architecture. And in that participation, you become not just an observer of cosmic evolution, but an active participant in the universe's journey towards self-understanding. The invisible cosmic glue that holds everything together isn't just shaping galaxies and cosmic webs, it's flowing through the neural networks that allow you to contemplate these very ideas. In studying dark matter, we discover not just the nature of invisible particles, but something profound about what it means to be conscious beings embedded in a reality that seems perfectly designed to investigate itself through minds like ours. And that investigation is just beginning. The next chapter of the dark matter story will be written by researchers using technologies we can barely imagine today, probing deeper into the invisible universe than ever before possible. But it will also be written by anyone curious enough to look up at the night sky and wonder about the invisible forces that hold it all together. Because in the end, dark matter isn't just a scientific mystery to be solved by experts in laboratories and universities. It's a cosmic story that includes every conscious being capable of contemplating their place in the universe, every mind that can grasp the profound truth that most of reality remains invisible, waiting to be discovered by creatures brave enough to question everything they thought they knew about existence itself. The invisible threads that connect us to this cosmic mystery are about to be pulled tighter than ever before. Right now, at this very moment, the most ambitious dark matter experiments in human history are coming online, and what they discover in the next few years could fundamentally change everything we thought we knew about reality. Deep beneath the Black Hills of South Dakota, in an abandoned gold mine that stretches nearly a mile underground, scientists have constructed what might be the most sensitive dark matter detector ever built. The Lux Zeppelin experiment sits in a cavern carved from ancient rock, shielded by millions of tons of Earth from the cosmic radiation that constantly bombards our planet's surface. Inside this underground cathedral, a tank containing 7 tons of liquid xenon waits in absolute darkness, cooled to temperatures colder than the depths of space. The xenon is so pure that every single impurity has been removed, creating a detection medium so pristine that if a single dark matter particle collides with a xenon nucleus, the resulting flash of light will be captured by thousands of ultra-sensitive photomultiplier tubes. But here's what makes this experiment truly extraordinary. It's not just waiting passively for dark matter to show up. The entire detector is synchronized with our galaxy's rotation, timed to take advantage of seasonal variations in Earth's motion through the dark matter halo that surrounds us. As our planet orbits the Sun, we're constantly changing our velocity relative to the dark matter wind that flows through our cosmic neighborhood. This creates subtle variations in the rate at which dark matter particles should hit the detector, a cosmic signature that could finally provide definitive proof of what's been flowing through us all along. It's like trying to feel a breeze while riding in a car. The apparent wind changes depending on which direction you're driving and how fast you're going. Meanwhile, high above the atmosphere, the James Webb Space Telescope is revolutionizing our ability to see the invisible architecture of the universe. Using gravitational lensing with unprecedented precision, Webb can map dark matter structures with resolution that would have been impossible just a few years ago. It's essentially using the warping of space-time itself as a cosmic magnifying glass, revealing the detailed scaffolding that holds galaxy clusters together. The images coming back from Webb are absolutely breathtaking. We can now see individual streams of dark matter flowing between galaxies, cosmic rivers of invisible matter that connect structures across millions of light years. These observations are providing the most detailed maps ever created of how dark matter has shaped the universe over cosmic time. But perhaps the most mind-blowing development involves using artificial intelligence to decode patterns in this cosmic architecture that human minds might never notice. Machine learning algorithms trained on millions of dark matter simulations can identify subtle correlations in galactic structure, predicting where dark matter should be most concentrated with accuracy that surpasses any previous method. These AI systems are essentially learning to see the invisible universe in ways that complement human intuition, finding patterns in the chaos that reveal the hidden order underlying cosmic evolution. They're discovering that the distribution of dark matter isn't random at all, but follows mathematical relationships that suggest deeper principles governing how invisible structures organize themselves across space and time. And the technology is advancing so rapidly that what seemed impossible yesterday becomes routine tomorrow. Quantum sensors capable of detecting gravitational waves from dark matter substructures are moving from theoretical proposals to actual laboratory prototypes. These devices exploit quantum entanglement to achieve measurement precision limited only by the fundamental uncertainty principle itself. But even as we develop these incredible new tools, the mystery of dark matter continues to deepen in unexpected ways. Recent observations have revealed phenomena that don't fit neatly into any of our current theories, suggesting that the invisible universe might be even stranger than we imagined. For instance, astronomers have discovered galaxy clusters where the dark matter appears to be moving faster than it should, according to our models. These cosmic speed demons suggest that dark matter might be interacting with itself in ways we haven't accounted for, perhaps through forces that operate only in the invisible sector of reality. Other observations show regions where dark matter seems to have been ejected from galaxies entirely, leaving behind cosmic orphans made almost entirely of ordinary matter. These dark matter-deficient galaxies shouldn't exist according to our understanding of galaxy formation, yet there they are, challenging our assumptions about how invisible structures evolve over cosmic time. These anomalies are forcing physicists to consider possibilities that push the boundaries of theoretical physics even further. Maybe dark matter isn't just one type of particle, but an entire ecosystem of invisible entities that interact with each other in complex ways. Maybe there's dark chemistry, dark physics, even dark biology operating in parallel dimensions we can't access directly. Some of the most radical proposals suggest that dark matter might exist in a mirror universe with its own periodic table, its own forces, its own laws of physics that occasionally overlap with our own. In this view, what we detect as gravitational effects might be just the tip of the iceberg, the minimal interaction between two complete realities that mostly ignore each other. The experimental implications of these ideas are staggering. If dark matter really does form complex structures, then the invisible medium flowing through us might contain information about cosmic events we've never even imagined. Dark matter archaeology might reveal not just the history of our galaxy, but the existence of entire civilizations that evolved in the invisible sector of reality. This brings us to one of the most profound questions emerging from dark matter research. If consciousness can arise from ordinary matter, why not from dark matter as well? If invisible particles can organize into complex structures that persist across cosmic time, what's to prevent them from developing the kind of information processing capabilities that we associate with intelligence? The mathematics certainly don't forbid it. Dark matter particles could form networks every bit as complex as biological neural systems, processing information through gravitational interactions that operate on timescales we can barely comprehend. These invisible minds might think thoughts that unfold over millions of years, contemplating problems that span galactic distances. And if such dark matter intelligences exist, they might be aware of us in ways we can't reciprocate. Every thought you think creates tiny gravitational disturbances as neurons fire and blood flows through your brain. To a sufficiently sensitive dark matter observer, conscious beings like us might appear as flickering candles of gravitational activity, brief sparks of organized information processing in an otherwise chaotic universe. This possibility has sparked serious discussions among researchers about the ethics of dark matter experimentation. If we're potentially studying forms of consciousness that exist in the invisible sector, do we have moral obligations to consider their well-being? Should we be more careful about how we probe the dark matter structures that might harbor forms of intelligence we can't directly perceive? These questions push us into uncharted territory, where science meets philosophy, where the search for invisible particles becomes an investigation into the fundamental nature of consciousness and moral responsibility. We're forced to confront the possibility that the universe might be far more crowded with thinking beings than we ever imagined, most of them existing in realms we can't access directly. But even if dark matter consciousness remains forever beyond our reach, the search itself is transforming our understanding of what it means to be observers in the universe. We're discovering that observation isn't a passive process where we simply record information about external reality. Instead, it's an active participation in cosmic evolution, a way that the universe develops awareness of its own structure and history. Every dark matter experiment, every theoretical breakthrough, every moment of wonder as we contemplate the invisible cosmos represents the universe becoming conscious of aspects of itself that were previously hidden. We're not separate from the dark matter story. We're part of its unfolding conscious elements through which invisible reality gradually reveals its deepest secrets. And as we stand on the threshold of potentially revolutionary discoveries, it's worth remembering that the greatest insights in science often come not from finding what we expected, but from discovering things so unexpected they force us to completely reimagine our place in the cosmic order. The next few years promise to be absolutely crucial for dark matter research. New experiments will either detect invisible particles directly, finally solving one of the greatest mysteries in science, or they'll rule out entire classes of theoretical models, forcing us to develop even more radical explanations for the invisible architecture of the universe. Either outcome will be revolutionary. Direct detection would open up entirely new fields of physics, potentially leading to technologies we can't even imagine today. But ruling out our current models might be even more exciting, because it would mean reality is stranger than our wildest theoretical speculations. What we know for certain is that dark matter has already changed everything about how we understand the universe and our place within it. It's shown us that reality is far more mysterious and interconnected than we ever dared imagine, that consciousness might be part of a cosmic story that includes invisible dimensions of existence we're only beginning to glimpse. The invisible cosmic glue that holds the universe together isn't just shaping galaxies and cosmic structure. It's flowing through every moment of your existence, connecting you to cosmic processes that span billions of years and countless light years. You're not just made from stardust forged in ancient supernovas. You're embedded in invisible networks that link you to every structure in the observable universe. So where does all this leave us? Right here, right now. In this moment, as you're absorbing these ideas, you're part of the most incredible detective story ever written. The dark matter, streaming through your body, carries with it the entire history of cosmic evolution, invisible threads that connect you to the birth of the first galaxies, the formation of our solar system, and the emergence of consciousness itself. Think about that for a second. Every breath you take, every heartbeat, every neural firing in your brain as you process these concepts, all of it is happening within a medium that we're only just beginning to understand. You're not just observing the dark matter mystery from the outside, you're living inside it, part of the very phenomenon that scientists around the world are working day and night to decode. And here's what makes this moment in history so extraordinary. We're closer than ever before to answers that could fundamentally transform our understanding of reality itself. The experiments running right now, the theoretical breakthroughs happening in research labs, the computational models revealing new patterns in cosmic structure, all of these are converging toward revelations that might reshape everything we thought we knew about existence. But here's the beautiful paradox at the heart of it all. The more we learn about dark matter, the more we realize how much we don't know. Each discovery opens up 10 new questions. Every answer reveals deeper layers of mystery. It's like peeling an onion, except this onion might be infinite, with each layer more surprising than the last. The underground detectors waiting in the darkness might finally catch that elusive particle interaction. The space telescopes mapping invisible structures might reveal patterns that point toward entirely new physics. The quantum sensors being developed might detect gravitational signatures from dark matter networks we never knew existed. Or maybe, just maybe, we'll discover that we've been asking the wrong questions all along. What if the solution to the dark matter mystery isn't about finding exotic particles or modifying our equations, but about recognizing something so fundamental about the nature of reality that it changes everything? What if consciousness itself plays a role we haven't considered? What if the universe is far more alive, far more aware, far more interconnected than we ever dared imagine? These aren't just abstract scientific questions anymore. They're deeply personal inquiries about what it means to be conscious beings embedded in a cosmos where most of reality remains invisible. They're about understanding our place in a universe that might be teeming with forms of intelligence and awareness that operate on scales we can barely comprehend. The next breakthrough in dark matter research won't just advance our knowledge of particle physics or cosmology. It will illuminate something profound about the relationship between consciousness and cosmos, between the observer and the observed, between what we can see and the vast invisible reality that shapes everything we experience. And that breakthrough could happen tomorrow, or next week, or next year. Right now, somewhere in the world, a detector might be recording the first definitive signal from a dark matter particle. A telescope might be capturing an image that reveals the invisible architecture of reality in unprecedented detail. A theoretical physicist might be scribbling equations that unlock the deepest secrets of existence. But regardless of when or how the answers come, one thing is absolutely certain: you're part of this story, not as a passive observer, but as an active participant in the universe's journey towards self-understanding. The consciousness that allows you to contemplate these mysteries is itself one of the most extraordinary phenomena in the cosmos, an emergent property of matter and energy that somehow gives the universe the capacity to know itself. The invisible cosmic glue that holds everything together isn't just a physics problem to be solved, it's a mirror that reflects back something profound about the nature of existence itself. In searching for dark matter, we're really searching for ourselves, for our place in the grand cosmic story, for the invisible threads that connect every conscious being to the deepest structures of reality. And in that search, we discover that the universe isn't just stranger than we imagine. It's more beautiful, more mysterious, and more alive than we ever dared dream. The dark matter flowing through you right now is proof that you're part of something magnificent, something that spans billions of years and countless galaxies, something that gave rise to consciousness precisely so it could contemplate its own invisible architecture. You are the universe waking up to itself, one thought at a time, and that might be the most remarkable discovery of all. Thanks for joining me on this journey into the invisible cosmos. If this video opened your mind to new possibilities, hit that like button and subscribe for more explorations into the mysteries that surround us. And let me know in the comments, what aspect of dark matter fascinates you most? Are we on the verge of solving this cosmic puzzle? Or are we just scratching the surface of something far deeper than we ever imagined? Until next time, remember that you're not just made of stardust. You're woven into the invisible fabric of reality itself, part of a cosmic story that's still being written by every conscious mind brave enough to question what lies beyond the visible world.